Hello students, welcome to the lecture of Fundamental of Data Structures. In the last lecture we have seen space complexity as one of the performance measure for algorithm. Now we will see time complexity is another measure for the algorithm. Just like in space complexity, time complexity also it is a sum of compile time plus runtime. So time required to compile the program and time required to run that particular program is nothing but the time complexity of the algorithm. We can run the program without recompiling we can execute our program without recompiling our program every time. So that's why when we are calculating time complexity of any algorithm, we are not considering compile time only on based on runtime we are calculating time complexity of any algorithm. One well-known method for calculating time complexity, it is a step count method. Now how we calculate the step count? So to calculate the step count of a program, first of all we have to list out the number of steps which are contributing for the number of steps contributing for executing each statement. So first of all we have to find out what are the statements present in the program. For every statement we have to calculate step count. Step count. So step count we are calculating by using step per execution. Step per execution into frequency of that statement, how many times it is executing in that program, multiplication of that step per execution and the frequency of the statement, both multiplication of that, it gives us step count for that particular statement. Now what is the step per execution of each statement? In our program, multiple types of statements are available. We will see for every statement what is the step per execution. So comments. In program we are writing comments for giving the information about that particular statement. But comments are not executed at runtime. That's why step per execution for the comment statement it is 0. Then declaration statements are there. We are defining different variables, constant, then user defined data types. We are declaring prototypes of functions. So these are not executing at the time of at the time of execution. That's why the step per execution for such statement is also 0. Then expressions or the assignment statement. So if we are writing some variable equal to expression like C is equals to A plus B. So A plus B is a one expression. So its step count it is considered as a 1. Now in that expression maybe multiple operators are available. Okay, so to execute this statement maybe it is going to execute multiple statements, but still for calculating purpose, for calculating time complexity, we are just considering that if one assignment statement is there in expression, n number of operators are present, but still that assignment operator step execution time we are considering it as a 1. Then loops are there, iterative statements are there in program. Then for loops also, initialization we will consider that it is a 1 step count for that. Expression, some conditional statements we are writing, based on that your loop is going to terminate, so its step count is 1. Increment statement is there, its step count is 1. So and then whatever the number of statements written inside that, accordingly what type of statements are they, their step execution will be considered. Then switch statements are there. If I have switch and then condition we are specifying. So for switch, 1 step count is there, and for which case it is going, its step count will be 1 for that case and addition of all the previous cases which it is executing. Like if condition is true for a case 3. So step count for that, it will be one execution for case 1, second for case 2, and then in the third execution it is going to case 3. But to go to case 3, first 2 it is checking. That's why its step count will be addition of all the preceding conditions plus 1. That will be the step count considered for the switch statement. The conditional statement. So as we have if, then some conditional expression, then else, and then some expression. So in this, each part is assigned number of steps corresponding to whatever expression we have written. So if suppose there we have written the expression like a less than b, so we are saying that for this if and condition, one step count is there. In the else, again some expression is present. So what expression is there, for that expression one step count will be considered. Function invocation. Function invocation means when we are calling the function. So when we are calling a function, we are considering step count of that function call, it is 1. Okay, normally when we are saying function we are calling, if it is without parameters, then its step count will be 1. But to that we are passing some values, some parameters which are passed by value we are doing, then that function call will have n. If n parameters we are passing by pass by value, then its step count will be n. Because when we are saying pass by value, so when pass by value we are doing, then in the function it is going to create another object for that variable. Okay, so that's why that assignment is going to happen in the function. That's why the step count for that function call, that will be whatever n number of parameters passed by value. Passed by reference, it will not matter because it is a reference. It is going to refer memory allocation of that variable itself. So there is no creation of the new formal variables. So that's why for function invocation, its step count will be depending on pass by value parameter. Then new and new delete functions which are dynamically allocating memory for the variable, in that its step count is 1. Even constructor, destructor, they are also considered as a functions. So how functions are working? Similarly, your constructor and destructor are also working. Then jump statements are there, like continue is there, break is there, return statement is there. Its step count is 1. And if any expression is written that. So normally when we are saying expression, if it is present in your any statement, like in conditional statement, in return statement, or maybe in the loop statement, though your expression is complex, to calculate manually, to calculate the time complexity, we are just taking its step count as a 1. Okay, we will see one example like we have seen for space complexity. So same function, addition of n numbers. So in that, now we have to calculate the time complexity of this. So what we have seen, we have to find out the step counts. Okay, to find out the step count, first I have to find out what are the multiple steps which are going to execute at runtime. So that's why here we are saying, like first statement is that int sum. So we are saying that is not executing at the runtime, so nothing will be taken. Opening braces is there, its step execution is not there, that's why its step execution is 0. Now int s equals to 0. So this is assignment statement. Okay, this is assignment statement. So assignment statement, we are saying that its step execution is 1. Then for I equals to 0, I less than n, and for I plus plus. Okay, by considering this, for is one statement. We are saying that these are the three different expressions, three different statements. But now here, as if we are considering that for is complete one statement. So its step execution will be 1. In for, we are just doing the addition of I elements. So its step execution will be 1. We are not calculating frequency. Okay, this is just execution, means when I am writing this, how many statements it is going to execute. And then after doing addition, it is return statement will be there. In that, return is going to return that to the main. Its step execution is 0. It's 1, and then closing braces it is 0. Now we will see frequency. When I am executing this statement, how many times these statements are going to execute. So we know that int s equals to 0, it is going to execute once, okay, as it is not in the loop or anything, so that it is going to execute once. Then for statement it is going to execute n plus 1 number of time, like when I is equals to 0, so it will start from 0, okay, and it will execute till I is less than n. So consider, if I is 5, then this for statement it is going to execute for I is equals to 0, then I is equals to 1, I is equals to 2, I is equals to 3, I is equals to 4, and even for I is equals to 5, because it is going to check that condition. Okay, though it will not go inside the loop, but it will check the conditional statement. So for, we are saying it is one statement which is combination of all this initialization, condition, and the incrementation. So this for loop statement, it is going to execute n plus 1 number of times. So frequency of that statement is n plus 1 number, n plus 1. Inside for, we are writing s is equal to s plus ai. That is going to execute only n number of time. When s is equals to, when I is equals to 0, it will go inside and a of I, 0th element, will be added to s. Then for I is equals to 1, a of 1 will be added to s. Like that, a of 0, a of 1, a of 2, 3, 4, and 5. Such that 5 number of times s is equals to s plus ai will be executing. That's why its frequency count is n. And return, it is going to execute only once. So return will be 1. So now we have step execution count and frequency count. We will multiply this. So total step count we are getting, first will be 0, then 1, it's n plus 1, n. So if we are adding complete this, we are getting 2n plus 1, 2n plus 3. So we can cross check that when I am passing n is 3, so it is going to execute 9 statements for getting sum of 3 elements. Okay, so like that we can say that space complexity, time for this code, it is proportional to the n what we are passing. So time complexity, it is order of n. It is, its function will be f of n is equals to 2n plus 3. So as n increases, your number of steps it is executing, that also it is increasing, and similarly to execute the the time required to execute that statement, that is also going to execute. Now same function recursively when we are implementing, what will be the effect on time complexity? So same function which we have written last time, step count. So for opening braces it is 0. If n is less than 0, it is conditional statement. So its step count is 1. Return, its step count is 1. Else, again its step count is 1. Return, so this is return statement, its step count is 1. So first we are identifying step execution, that how much time is required to execute this statement, or how many statement internally it is executing for this statement. Now frequency we will see. So frequency we know R sum, first time it will be 0 for opening braces. Then if n less than 0, how many time it is going to execute that condition? It is going to check that it is going to execute one time. Okay, when it is true, it is going to execute that and then return will be executing 1. Else t into r sum n minus 1 number of times return statement, means this calling to itself, it is going to execute. So when we are doing addition of this, multiplication of this, we will get that 2 plus t of n minus 1, this much time is required to execute recursive function. Now here you can see if n I am passing 5, okay, so the R function, it is going to execute how many times? That will be 4 times. Okay, for t is equals to when n is 5, for 4 it is going to call function, for 3, for 2 and for 1 it is going to call. That's why internally it is calling a function n minus 1 number of times. So it is saying that time required to execute some function n minus 1 number of time, plus these two statements are compulsory. If n is less than 0, return 0. So even though if I am passing 0 to n value is equals to 0 to this function, it is just going to execute two statements. Okay, but when n is greater than 1, then it will be 2 plus time required to execute n minus 1 number of time this function. So always your time complexity for recursive function, it will be like a function in terms of how many times recursively you are calling that function itself. Okay, so this function, this complexity is 2 plus t of R sum function you are executing n minus 1 number of times. Again we will see factorial function. Okay, its step count, step execution and then total step count. So factorial function, we are passing int x. So here we know that int answer equals to 1. So this is the initialization, so that is going to execute at runtime. So int answer equals to 1, its step count is 1. While and conditional statement, its step execution is 1. Answer into x. Now how many times this step execution will be 1 x, because these are just assignment operations. Okay, assignment, what is the expression you have? Once one is a step execution. Now frequency count, that is complex, that we need to work properly on that. So answer equals to 1, it is going to execute only once. Then while condition, that it is going to execute when x I am passing x number of times, it is going to execute that. Okay, check it. Suppose I am passing 5 to the function. Okay, so first time 5 is greater than 1, then 5 will, so first while checking, then 4 is greater than 1, 3 is greater than 1, 2 is greater than 1 and 1 is greater than 1. So 5 times while statement is going to execute. Obviously at the 5th time condition is false, so it will come out. So statements which are present inside while, they will execute x minus 1 number of time. So both the statements having frequency count, that will be x minus 1, and return it is going to execute only once. So frequencies we can calculate like this. Total step count, it is a multiplication of, for every step execution into its frequency, and then addition of all will be giving us the time complexity. So here we can say it is 3x, or in general we can say it is 3n. So thrice whatever the value of n you are passing, that many executions, step executions it is performing in iterative function of factorial. Again its complexity is order of n. Okay, time complexity is order of n. Recursive function, again in this opening braces step execution is 0. If x equals to 1, step execution is 1. Return step execution is 1. Else step execution is 1. And return statement, its step execution is also 1. So for all 4 statements, step execution is 1. Count. So we know if x equals to 1, only once it is going to execute and its value will become true. Okay. Else it will not execute, and return statement it is going to execute t of x minus 1 number of times. Okay, so as factorial 5 we want to calculate, it is going to execute factorial 4, factorial 3, factorial 2 and then factorial 1. So x minus 1 number of time, again rfact function it is going to call. So its summation will be 2 plus t of r n minus 1 or x minus 1. That is the time required for executing factorial function. Okay. So this way we can find complexity and space complexity for every program whatever we are writing. We will again recall that space complexity, it has fixed space and fixed requirement space and the variable space requirement. Fixed, as it is fixed, compile time only we are allocating. That's why while calculating space complexity we are just considering variable space requirement is there. In case of time complexity also we are just considering time required to execute that statements and not the compilation time. Only execution time that we are considering. The statements which are executing at runtime, that only we are considering. And based on that, we are finding time complexity for every code. So we have seen 2 small examples how to calculate time and space complexity. This is the assignment for you. You have to write program for this, small function for this. Only function you have to concentrate. No need to consider like write a main function and accepting a variable and all. Only functions you write and try to find out, calculate space and time complexity for these functions, these problems whichever I have mentioned here. Okay, next we will discuss how, what is the time and space complexity for these functions one by one, but for that first you have to try out it and then we will solve it. These are the references.